Hey everybody, Mr. Regan here, and today we're looking at your Task 4 guide video that's going to focus on reviewing your actual Task 3 that you completed, where you looked at this evolutionary tree diagram and answered some questions in the Amplify page. So here's what this video is looking to accomplish. Number one, we're looking to understand how to read an evolutionary tree diagram. We're going to go over that today, and we're going to be looking to decide whether or not we need to change any of our answers in the previous task, okay? So as we go through the video, you're going to come back to the survey when you're done and ask yourselves, okay, do I understand how to read the tree diagram, and do I need to change any of my answers? If the answer for that is yes, then you'll put your X there. If you understand how to read the tree diagram, but you need to change your answers, you obviously put your X there. And if we're obviously stuck, don't quite know how to read the tree diagram, and we need help so we can then change our answers, we put our X there, and then obviously check in with me so we can obviously go over that together. So let's go ahead and take a look at how we read our tree diagram, our evolutionary tree diagram, and then decide whether or not we need to change our answers. So this was the diagram that you had to review and then answer questions about. And I didn't give you a lot of information because I wanted to see what you could pick out of this. But whenever we look at this evolutionary tree, what we're really looking at is what relationship our organisms have with our descendant organisms have with a common ancestral population. Now, before I move on, I first want to talk about these organisms over here on the right side of our tree. Okay, these organisms, the blue whale and the human, are obviously one organism within this species, but they represent an entire population. So even though we have one in the picture, this blue whale represents every blue whale in the population. Same with the human. So that being said, when we talk about these different common ancestor populations and these descendant populations, please know we're talking about the full population. So let's look at why we call it a tree. We call it a tree because we have these different branches that stem off of one another to show a relationship. So the very first branch here stems off into two branches to show that there's some population of organism that has a relationship, an evolutionary relationship with these two organisms, that they're connected by this population. Now, the yellow lines themselves show that relationship between the common ancestral population and these two descendant population, but we don't quite know what this population is. In other words, we don't really know what this organism is, what it looks like. We don't know exactly quite what the organism could be yet. We would need to go dig up some fossils. We would need to go explore our records to figure out what organism is the common ancestor of these descendants. Okay. And to figure that out, we have to look at what traits they have. And that's where, well, what we see underneath the populations come in. So underneath here, we have these traits. And the traits here by the common ancestor population are the traits that both of our descendants have in common. So these here should be the same traits that we see over here within our organism. So we have backbone. They both have backbones. They both have radius and ulnas, so on and so forth. The common ancestor always has the same traits as its descendants. But not all descendants have the same traits as each other. So structures that produce milk and so on. Now, when we're looking at our descendant species, we see that they have all of these different traits in common. But what we also see is that they have some unique traits that make them their own unique populations and species. So for example, ability to walk upright, tail flukes for swimming, and so on. So when we look at these trees, we read them left to right, knowing that the descendants always branch off of the common ancestor that we see here. We see that these organisms represent the full population and that they have some shared traits or body structures with one another that came from their common ancestor, some ancestor that passed those traits down to them. They also have their own unique traits that allow them to be very unique populations and species. Now, these diagrams here, folks, they do have some limitations. For example, we don't quite know how they evolved, okay? So we don't know how it is that these common ancestors gave rise to these two different types of organisms. Okay. We also don't know what happened over time. In other words, how long did this take, Nat? How long did it take? When did these organisms become different from one another? What occurred? All of those sort of questions. These diagrams simply help us organize our thinking and show who's related to who. They don't actually explain the science that we've come to know in our previous lessons and units, but they help us to organize who's related to who through evolution. So that's how we go about reading our and interpreting our evolutionary tree here. Now that we've looked at it, your job is to go through and review your questions and your answers and decide, okay, do I truly understand how to read this evolutionary tree? And do I need to change any of my answers now that I do know how to read the evolutionary tree? So what you'll do is you go and double check your answers. And when you're done, you'll come back and decide, okay, what happened? Do I understand how the tree works and how to read it? And did I change anything? If the answer is no, you'll put your X there. If you know how to read it but had to make a few changes, you'll put your X there. And if you're confused on how to read it still and you don't know how to make changes, put your X there and reach out to me. At this point, let me know if you guys have any questions, and good luck reviewing your answers.